Hello everyone, welcome back to the channel Devotion of Knowledge. Today we are back again with another and very interesting video. In this video we are gonna understand CAP theorem, which is a short form for three terms which contains consistency, availability and partition tolerance. Basically this theorem is used to understand system design, but I am not that master of system design, because system design in itself is a vast topic. But I was just scrolling through YouTube, and I just got to understand about this CAP theorem, and I just read some documentation, and I felt this uh, theorem very interesting. So I thought, why not to make a video and make you guys as well also aware about this theorem. So see, this theorem does not require you anyone to be a computer engineer or anyone, but this is such thing that everyone can relate to their day-to-day life, because this is very easy to understand yet very interesting theorem, CAP theorem. So let us understand each and every term which is included in CAP theorem. So the first term is consistency. See, whatever data that we are using or seeing on website, any application, etc., on internet, it is basically stored somewhere in database. So database is something, it might be somewhere in US, in India, and it contains data. मीन्स डेटाबेस मतलब ये कोई हार्ड डिस्क या कोई बड़ा सा सर्वर होता है विच स्टोर्स द डेटा. नाउ whenever some person is trying to access the data, for example this is the computer CLI client. Let us take example of railways. For example, I want to book a ticket for Vande Bharat tomorrow morning. So the client will go on to the website, a server, and there is some data stored in the website, that how many seats are available, seats available, seats booked, and this corresponding data will be sent on the machine of client. Now on the same time, this is client 1. On the same time, client 2 is also looking for the same website, and client 2 books the seat. For example, he books the seat number 12. At the same time, for example, this is the chunk of the data which stores information about seat number 12. Now it should get updated that this seat is booked. So on the same time, the client 1 is watching, or is exploring for Vande Bharat, he should be notified, or the UI or the data that he is getting here should get updated directly or within no time, because otherwise client 1 will see that seat number 12 is available over here, but in real seat number 12 is already booked. So this client 1 will undergo dirty read. This term is called as dirty read, because in real that seat is no more available for booking, but this client is still getting the data that seat number 12 is available. So this is called as dirty read, because the data has not been updated. So this term is called as consistent. The data should be consistent to each and every client or each and every user who is getting data from the server. Okay, this was the one term. The next term is availability. Now whenever there is a result declared on CBSE website, the site gets crashed within very short period of time, because there are large number of students who are trying to access the data from the server. So the website is not available and gets crashed. So we say that website is not available. It means the availability of the website is very low, because website is not available whole time for the client. While you say example of Google, hardly in couple of years Google's website is down. Otherwise Google's availability is 99.9%. Means it is always up, whether they are undergoing any kind of maintenance, I would say, updation, anything, whatever they are undergoing, but their availability is always up to the mark. And those who are not aware, every day railways website is not available every midnight, because midnight means around after 12 or 1 they are undergoing some kind of maintenance updation, we don't know. But availability of the railways website is not there in night. So availability means the website or the service that any application website is providing, it should be always available to the user. Third term is partition tolerance. Now, believe, for example, Amazon is there, Amazon shopping website. So there is one module of authentication. There is one feature of adding elements to cart, booking. Then another module is of watching the items. Watching means searching for items. There are n number of modules. Now see, whenever the website is deployed, really, this is called as microservice or distributed system. Means each website or service is distributed into n number of sub modules which are responsible, which makes it, you know, more less dependent on each other modules. And this is the ideal way of creating large scale applications like Amazon, Netflix, etc. So for example, this authentication module is deployed on a server in US. For example, in US it is deployed. Now see, there is not only a single server, there are some another servers also deployed for backup. For example, there is a storm in one area where this server is deployed. So due to some natural disasters such as storm, heavy rain, this server gets uh, unavailable because of natural reasons, anything, earthquake, etc. So at that time, two extra servers are kept on standby, and immediately they are switched for service. So if there is not any extra module, for example, for searching items there is only one module or only one server. So because of some reason, this gets unavailable for some time. So for searching or watching the items, there is not any server available. So this module is not cancelled, or it's not available for the whole service. So partition tolerance means there should be, if partition means if some service is not available, then the system should tolerate and it should have some another backup module. So this is main idea behind partition tolerance. Now we understood what is consistency, what is availability, what is partition tolerance. What is this CAP theorem? Okay, let us move towards understanding of the main crux. Now see, this is the triangle. Each vertex stands for CAP. This is consistency. This is availability. And this is partition tolerance. Partition tolerance. Let me make sure the recording is going on. Yeah, it is going on. So CAP theorem states that one can only satisfy two at a time. If one is providing any kind of service, CAP theorem states that any company or any service providing company or anyone on the planet Earth can provide only either of two. If either consistency availability partition tolerance, or partition tolerance and consistency. Let me explain how. For example, consistency and availability. It means that website should be always available. Website should be always available, as well as if some changes are made into the database, they should be immediate. Means it should be consistent. It is only possible when there is only one system or only one server. Because if there are multiple servers available, for example, if a person makes change in this server, so there is some time latency, I would say TL latency, to update the servers throughout the world. In real life applications, there might be n number of servers. So there is some latency TL to update the data on each and every server. For example, this memory is changed, so it will take some time to update the data. So see, there is complete consistency. It means this time should not be there. It means there will be always one module only, or it will be always in the case of monolithic monolithic architecture. It means there is only one single module or only one database which is undergoing everything. So if we are aiming for consistency as well as availability, then one has to compromise on partition tolerance, because there won't be any extra server to be kept as a backup. Another one is availability and partition tolerance. For example, you want to keep your system available all the time, as well as there is some partition tolerance. So it means, as we have taken example over here, if there is some change in the data, for example this is the memory changed, and you want to keep this server as well as this server available for the whole time, then you won't be able to modify this particular memory, because if you are willing to modify this memory, so it will take some time to modify the memory. For this t time, system will not be available because there is some updation going on in the memory over here as well as over here. So for t time, see, this t will be very small, for example some millisecond, microsecond, we are not concerned with the time. But for this t time, t system will not be available. So you will be getting consistency, but you are compromising our consistency here. So if you want to keep your system available for the whole time, then you won't be able to modify this chunk as well as this chunk of the memory over here. So you are compromising on consistency, because as this memory is not updated over here, so user might be seeing that seat number 12 is still available for the booking, because you are giving more priority to availability and partition tolerance. So you will be compromising on consistency. Let me erase this much part so that we can take another example very clearly. Okay. Now the third one is partition tolerance and consistency. Now this is the case. For example, see, this is the one server, second server, third server. Because it is not feasible to keep each and every module or the large scale application into single server. So there are multiple servers available. So partition tolerance is okay. Now consistency. Now for example, a user is booking here. For example, a user is booking a seat number 12. So this is also a data. This is also data. They all are synced. So if this seat is booked, so the data of seat number 12 here, it will be also modified in all the servers, because data should be consistent. Each and every user should be getting the same information. So it will take some time, time t, and time t, because they are in sync. So they have to be in communication that data over here is changed. So it will tell this and this, that data over of seat number 12 update. So while this memory is getting updated, for small period of time, let's say small t, the system will be unavailable because you are updating the memory. So you can't access and update the memory at the same time. So for this much amount of time, system will be down. So here you have to compromise on availability. See, that availability might be for very small time, but on large scale applications it might be some large 1 second, 2 second, we are not concerned. But you are compromising on availability, because it's not possible to provide consistency as well as availability at the same time. And if you are willing, then you should be compromising on partition tolerance, because C and A is only possible in monolithic architecture, and these two are for distributed systems. So yeah, I think CAP theorem you are able to understand. CAP theorem nothing states nothing, but you can either out of CAP, either you can go with C and A and P, or C and P, but you can't go with C, A and P all at the same time. So yes, I think this is it for the video. I hope you all have understood about the CAP theorem in depth, what it is trying to say. And yes, I believe it was not that tough. Everyone can understand this theorem, those who are connected or using internet, because the example that I have taken is very generous example, so everyone can understand. And yeah, this is it for the video. We'll meet in the next video very soon. Till then, keep learning, keep hardworking. Thank you very much.